been a while since I've done one of these. Hello, everybody, and welcome back to the Level Up series. In the last episode, we focused on wireless networking, and we talked about how devices connect without cables, how wireless networks are used in homes and businesses, and some of the common issues that can cause users to lose connectivity. Now, we're going to shift from how devices connect to where modern IT services actually live, because today, a user may not be opening an application that runs only within the bounds of their laptop or network. Their email may live in Microsoft 365 or Google Workspace. Their files may live in OneDrive, SharePoint, Google Drive, Dropbox, or some other cloud storage platform. Their company desktop may be running in a virtual desktop environment, which is a lot more secure than normal. Their server may be a virtual machine. Their backups may be stored in the cloud. Their identity may be managed through a cloud login provider. And their applications may be delivered through SaaS platforms, remote apps, or cloud-hosted services. So for this episode, we're not going to reteach what we learned in the previous episode, such as Wi-Fi standards, SSIDs, wireless frequencies, or encryption. That was episode 6. This episode is going to be about cloud computing, virtualization, and modern network services. For the CompTIA A+, you do not need to be a cloud architect or even a cloud engineer. You don't need to be able to design an entire Azure, AWS, or Google Cloud environment, but you do need to understand the basic terminology because these concepts show up everywhere in modern IT support and all over future CompTIA exams. By the end of this episode, you should be able to explain what cloud computing is, why companies use cloud services, the difference between public, private, hybrid, and community cloud, the difference between IaaS, PaaS, SaaS, what shared responsibility means, what virtualization is, what virtual machines and hypervisors do, the differences between type 1 and type 2 hypervisors, what containers are at a basic level, what virtual desktops are, and finally, how to troubleshoot cloud and virtualization problems without confusing them with basic wireless issues. Time to level up. For CompTIA A+ Core 1, this episode fits into the area of virtualization and cloud computing. That means you should understand the concepts, the vocabulary, and the practical troubleshooting mindset. This is not a deep cloud engineering course. This is just the foundation you need as a help desk technician, desktop support technician, junior system administrator, or even a future cybersecurity analyst. So we're going to start at the simplest terms. What is cloud computing? Well, cloud computing means using computing resources delivered over a network, usually the internet, instead of relying on local hardware owned and managed directly by your company. This can include a multitude of different things. We're talking about applications, servers, storage, databases, etc., etc. The simplest way to explain cloud computing is this. Instead of buying, installing, powering, cooling, and maintaining every single individual server yourself, you consume technology as a service from a provider. That provider could be Microsoft Azure, it could be Amazon Web Services, it could be Google Cloud, it could be Oracle Cloud, IBM Cloud, or some other cloud provider that's out there. But cloud computing is not only massive enterprise platforms. Most users interact with cloud services every single day, and then you don't even realize it. Microsoft 365 is a cloud-based productivity and email tool. Google Workspace is a cloud-based productivity and email tool. OneDrive is cloud storage. Google Drive is cloud storage. Dropbox, Salesforce, Zoom, ServiceNow, Slack. The important thing to remember here is that cloud computing isn't some magical thing. It's still very real servers. It's real storage. It's real networking. It's data centers with real security concerns. The difference is that the company may not directly own or manage all of the physical infrastructure. They're just consuming the resource as a service. That is the core idea of cloud computing. Knowledge check number 1. A small business no longer hosts its own email server. Instead, users access email through a web portal and Outlook, while the provider manages the back-end mail servers and storage. Which concept does this best describe? Local hosting, cloud computing, peer-to-peer networking, or on-premise virtualization? I'll give you guys a minute to think about your answer. Or 15 seconds. The correct answer is cloud computing. See, This is cloud computing because the business is consuming email as a service from a provider instead of hosting and maintaining the backend infrastructure itself. A is incorrect because the email is no longer locally hosted. C is incorrect because peer-to-peer networking involves devices sharing resources directly with each other. D is not the best answer because virtualization may be used behind the scenes, but the scenario is mainly describing cloud-based service delivery. Now, why does cloud computing matter for IT support? Let's make this a little bit more practical. Why should a help desk technician care about cloud computing? Because the troubleshooting process changes. In older environments, a user has had most tools installed locally. We're talking about local files, local applications, local servers, local authentication. But in modern environments, one user problem may involve several different services. Let's say a user says, my email isn't working. That could mean a lot of different things. It could mean the Outlook desktop app is broken. It could mean the web browser has cached bad data. It could mean the user's password expired. The user failed multi-factor authentication. The user's M365 license was removed. The mailbox is full. The account is disabled. There's a multitude of different reasons. The user could be blocked by security policy. The service is experiencing an outage. The user is trying to access the wrong mailbox, or the device has no internet connection. Again, this is why cloud knowledge matters. You need to ask better questions. Like, is this affecting one user or a ton of users? Can the user access the service from a different browser? Can the user access the service from a different device? Can other users access the same service? Is the user licensed for the service? Etc., etc. You get the point. Cloud troubleshooting is more about isolating the layer that's failing. The user sees one error message, but behind that error message, there may be a local device, a browser, an account, license, permission, cloud app, identity provider, or backend service. A good technician knows how to narrow it down. Question 2. A user reports that they cannot access the company's cloud-based ticketing system. Other users can access it normally. The user can browse other websites without any issue. What should the technician check first? A, the cloud provider's global service status page. B, the user's account, permissions, license, and authentication status. C, the office wireless access point configuration. Or D, the company firewall's uplink bandwidth. I'm going to give you guys a few seconds to answer. The correct answer here is B, the user's account, permissions, license, and authentication status. Since other users can access the system and this user can browse other websites, this is most likely a user-specific issue. The best first step here is to check the user's account, permissions, license, MFA, or authentication status. A isn't really the best step first because a global outage would likely affect a lot more users. C is highly unlikely because the user can browse other websites. D is unlikely because other users can access the service normally. So this is the kind of question where more than one answer may sound technical, but only one answer fits the scenario best. Now let's talk about why companies should use cloud computing. Companies using cloud computing can be for several major reasons. The big ones are scalability, availability, flexibility. Some other reasons include remote access, reduced hardware management, faster deployments, disaster recovery, and cost flexibility. Let's break those concepts down a little bit. So scalability means that resources can grow or shrink based on demand. If a company's website gets more traffic during a busy season, cloud resources can often be increased faster than buying and installing a whole new physical server. When the busy season ends, those resources can then be reduced again. That's what scalability is. Availability means the service may be designed to stay online even if part of the environment has an issue. Cloud providers often use multiple data centers, regions, redundancy, and failover methods in order to improve uptime. That doesn't mean that the cloud service can never go down, because they do, but cloud platforms are often designed with availability in mind. Flexibility means companies can choose the services that they need. Maybe they need virtual machines, maybe they need object storage, or managed databases, or identity services, or cloud backups, or even endpoint management. They don't have to build every single thing from scratch. Remote access is another major reason cloud is everywhere. Users can often access cloud services from their office, homes, hotels, airports, or mobile devices as long as they have the correct access and security controls. But here's the part that most people get wrong. Cloud does not automatically mean cheaper. Cloud changes the cost model. Instead of buying hardware up front, companies may pay for usage, storage, licenses, bandwidth, compute time, or subscriptions. That can be great when managed well. It can also get expensive fast if nobody's paying attention to it. A virtual machine left running all month is going to cost you money. Storage, backups, licenses, data transfers, cloud security tools all cost money. So don't say cloud is always cheaper. That's lazy and not always true. The better answer here is cloud can provide flexibility, scalability, and reduced hardware management, but still costs need to be monitored. Question 3. An online retailer expects a major increase in traffic during a holiday sale. The company wants to temporarily increase resources during the sale and reduce them afterward to control costs. Which cloud benefit is being used here? High availability, scalability, metered utilization, or fault tolerance? Pause the video and think through the best possible answer. The correct answer here is scalability. Scalability is ability to increase or decrease resources based on demand. A is close, but high availability focuses more on keeping services running during failures. C is related to cloud billing and tracking usage, but the scenario is mainly about changing resource levels. D focuses on continuing operation after a component fails, not adjusting capacity for demand. So again, this is about picking the best possible answer, not just the first answer that sounds cloud related. Now let's talk about cloud deployment models. A deployment model describes who owns, uses, or has access to the cloud environment. There are 4 main models. There is public cloud, private cloud, hybrid cloud, and community cloud. A public cloud is owned and operated by third-party cloud providers. The provider owns the infrastructure and many customers use services from that provider. Examples include Microsoft Azure, Amazon Web Services, and Google Cloud. Your company does not own the physical data center, you are using services hosted by the cloud provider. A private cloud is built for one organization. That organization may host in its own data center or a third-party provider may host it, but the resources are dedicated to that one organization, and this part matters. Private cloud does not automatically mean inside of your building. It means the cloud environment is dedicated to one organization. A private cloud is often used when companies want more control, dedicated resources, or specific compliance requirements. A hybrid cloud combines public cloud with private cloud or on-premise infrastructure. This is extremely common in today's environments. A company may keep some servers in its own data center while using Microsoft 365 for email, Azure for backups, and a SaaS platform for ticketing. That is hybrid. It's a mix. In the real world, many companies are hybrid whether they planned it that way or not. They may have old servers, cloud services, SaaS platforms, VPNs, identity integrations, and remote users all working together. Finally, a community cloud is shared by organizations that have similar needs. For example, several government agencies, healthcare organizations, universities, or research institutions may share an environment designed around common security or compliance requirements. For the A+, keep it simple. Public cloud is provider owned and shared by many customers. Private cloud is dedicated to one organization, hybrid cloud is a mix of public and private or on-premise systems, and community cloud is shared by organizations with similar needs. Question 4. A company uses Microsoft 365 for email, stores some backups in Azure, and still runs a legacy accounting server inside its own data center. Which deployment model does this best describe? Public cloud, private cloud, hybrid cloud, or community cloud? Pause the video and choose the best possible answer. The correct answer here is C, hybrid cloud. This is a hybrid cloud model because the company is using both cloud services and on-premise infrastructure. A is incomplete because the company still has local infrastructure. B is incomplete because the company is also using public cloud services. D would involve multiple organizations with similar requirements sharing a cloud environment. Hybrid is one of those answers you will see a lot when the scenario describes a mix. Question 5. A healthcare organization runs a dedicated cloud environment used only by its employees and internal applications. The environment is hosted by a third-party provider. However, the resources are not shared with other customers. Which deployment model is this? A public cloud, private cloud, a hybrid cloud, or a community cloud? Pause the video and think through the wording. The correct answer is B, private cloud. A private cloud is dedicated to one organization. It doesn't have to be physically located inside of the company's own building. A is incorrect because public cloud resources are shared across multiple customers. C is incorrect because this scenario doesn't describe a mix of public cloud and on-premise infrastructure or private resources. D is incorrect because the environment is not shared by multiple organizations with similar needs. The trap here is assuming that anything hosted by a third-party provider automatically means it's public cloud. That's not always true. Now let's talk about the different cloud service models. This answers different questions. How much does the provider manage, and how much does the customer manage? There are three main service models. We're talking about IaaS, PaaS, and SaaS. IaaS stands for Infrastructure as a Service. IaaS gives you access to infrastructure, such as virtual machines, storage, and networking. You aren't buying the physical servers, but you still manage a lot of what runs on top of it. For example, if you create a virtual machine in Azure or AWS, the provider manages the physical data center, hardware, power, cooling, and the underlying platform. But you manage the operating system, patching, applications, local firewall rules, user access, security settings, backups, and monitoring. IaaS gives you much more control, but it also gives you much more responsibility. PaaS stands for Platform as a Service. PaaS gives developers a managed platform for building and running applications. The provider manages more of the underlying infrastructure, and the customer focuses on the application, code, and data. For example, a developer might upload a web application to a managed cloud app platform and not directly manage the operating system underneath it. That's the point of PaaS. You focus on the application, not the server. SaaS stands for Software as a Service. This is the model most end users will deal with. SaaS is a complete application delivered via the internet. Examples of SaaS includes Microsoft 365, Google Workspace, Salesforce, Dropbox, Zoom, Slack, ServiceNow, Canva. You get the point. With SaaS, the provider manages most of the infrastructure and the application platform. The customer usually manages things like the users, the groups, licenses, permissions, data, security settings, authentication options, and configuration. A normal user doesn't care what server runs Microsoft Teams. They just open Teams and expect it to work. That is what SaaS is. The application is consumed as a service. The simplest way to remember it: IaaS gives you infrastructure, PaaS gives you a platform, and SaaS gives you software. Question 6. A system administrator creates a virtual machine in Azure, installs a server operating system, configures Windows updates, installs an application, and manages firewall settings inside the operating system. Which cloud service model is being used here? SaaS, PaaS, IaaS, or DaaS? Pause the video and choose the best answer. The correct answer here is IaaS. This is infrastructure as a service because the administrator is managing a virtual machine and the operating system running on it. A is incorrect because SaaS is a complete application delivered to users. B is incorrect because PaaS abstracts more of the operating system and server management. D is incorrect because DaaS refers to desktop as a service, not a general purpose server VM. Question 7. A user logs into a browser-based CRM system. The vendor manages the application, servers, updates, and backend infrastructure. The company manages user accounts, licenses, and permissions. Which cloud service model is this? Pause the video and think through the customer's responsibility. The correct answer here is SaaS. That is software as a service, because the user is accessing a complete application provided by the vendor. A is incorrect because the customer is not managing virtual machines or server infrastructure. B is incorrect because the customer is not deploying code to a managed development platform. D is a deployment model, not a service model. Question 8. A developer uploads application code to a cloud service app. The provider manages the operating system, runtime environment, scaling, and underlying servers. The developer mainly manages the application and data. Which cloud service model does this best describe? IaaS, PaaS, SaaS, or VDI? Pause the video and choose the best possible answer. The correct answer here is B, Platform as a Service, because the developer is using a managed platform to run an application without directly managing the server operating system. A would require more customer control over the virtual machines and operating systems. C would be a complete finished application for end users. D refers to virtual desktops, not application hosting platforms. Now we need to talk about one of the most important cloud concepts, shared responsibility. This means security and management responsibilities are split between the cloud provider and the customer. Cloud doesn't mean that the provider handles everything. Cloud doesn't mean that the customer has zero responsibility. The exact split depends on the service model. With IaaS, the customer manages more. With SaaS, the provider manages more. But the customer still has some responsibility. For example, in a SaaS email platform, the provider may manage the physical servers, the storage, the application infrastructure, the backend availability, the data center, the power and cooling, but the customer may still be responsible for creating and disabling user accounts, assigning licenses, enforcing MFA, managing permissions, configuring security policies, training users, protecting sensitive data, reviewing risky sign-ins, and responding to suspicious activity. This is where companies can get burned. They think, well, it's in the cloud, so it must be secure and it must not be my problem. No, that's not exactly how this works. A cloud provider can secure the platform, but the customer can still misconfigure access. A user can still get phished. An admin can still assign way too many permissions. A file can be shared publicly. An old account may be left active. MFA can be disabled. A password can be weak. So the better statement here is cloud providers secure the cloud infrastructure. Customers are responsible for securely using the cloud services. That idea matters in IT support and cybersecurity. Question 9. A company uses a SaaS email provider. The provider manages the mail platform and infrastructure. The company wants to reduce the risk of account compromise. Which task is most likely the company's responsibility? Replacing failed physical disks in the provider's storage array, configuring MFA and reviewing risky user sign-ins, installing firmware updates on the provider's servers, or maintaining the provider's data center cooling systems. Pause the video here and choose the best possible answer. The correct answer here is B, configuring MFA and reviewing risky user sign-ins. Even in SaaS, the customer is usually responsible for identity security, user access MFA, permissions, and data protection. A, C, and D are provider responsibilities. This is why cloud security is shared. The provider secures the platform, but the customer still has to configure and use it securely. Now let's move on to virtualization. Virtualization allows one physical computer or server to run multiple virtual systems. Instead of having one physical server for one workload, you can use virtualization to run multiple virtual machines on one physical host. Each virtual machine acts like its own computer. A virtual machine can have its own operating system, virtual CPU, virtual memory, virtual hard drive, virtual network adapter, applications, security settings, and system configuration. This is extremely common in IT. Before virtualization became standard, companies often had many physical servers, each running a separate workload. One server could be for file sharing, one could be for the database, one could be for an application, one for testing, one for backups. That could waste a lot of resources. A server might be sitting there using only one small percentage of its CPU and RAM most of the time. Virtualization is what has helped companies use hardware much more efficiently. One powerful server can host multiple VMs. Each VM thinks in its own system, but underneath, they're sharing the same physical hardware. Virtualization is also perfect for lab environments. If you're studying IT or cybersecurity, virtualization allows you to build practice environments without buying a pile of physical computers. You can run a Windows Server VM, a Linux VM, a Kali VM, a Firewall VM, and a Windows Client VM from one physical machine if your hardware can handle it. This is why virtualization is such a big deal. It is used in enterprise data centers, cloud platforms, software testing, cybersecurity labs, training environments, and disaster recovery. Question 10. A company has one powerful physical server running several separate Windows and Linux server instances. Each instance has its own operating system, virtual disk, memory allocation, and network adapter. Which technology is being used here? Clustering, virtualization, containerization, or load balancing? Pause the video and choose the best answer. The correct answer here is B, virtualization, because virtualization allows one physical host to run multiple VMs, each with its own operating system and virtual hardware. A is incorrect because clustering usually involves multiple systems working together for availability and performance. C is close, but containers do not usually include a full separate operating system for each instance. D distributes traffic across multiple resources, but doesn't describe running multiple operating systems on one host. Now let's talk about hypervisors. The software that creates and manages virtual machines is called a hypervisor. There are two main types of hypervisors. There's type 1 and type 2. A type 1 hypervisor runs directly on the physical hardware. This is also called a bare metal hypervisor. Examples include VMware ESXi, Microsoft Hyper-V, Proxmox VE, and Citrix Hypervisor. Type 1 hypervisors are very common in enterprise environments because they are designed to run production virtual machines more efficiently. A Type 2 hypervisor runs on top of an existing operating system. Examples include VirtualBox, VMware Workstation, VMware Fusion, and Parallels Desktop. For example, if you install VirtualBox on your Windows laptop, then create an Ubuntu VM, VirtualBox is acting like a Type 2 hypervisor. Your Windows laptop is the host, Ubuntu is the guest VM. For the A+, try to remember it like this. Type 1 runs directly on hardware. Type 2 runs inside existing operating systems. That is the primary difference. Question 11. A company installs VMware ESXi directly onto a physical server. Virtual machines run on top of ESXi without a traditional host operating system like Windows or Linux installed first. Which type of hypervisor is being used here? Type 1, Type 2, hosted, or application level? Pause the video and think through the wording. The correct answer here is A, a Type 1. Type 1 hypervisors run directly on the physical hardware. B and C describe hypervisors that run on top of an existing host operating system. D is not the standard A+ hypervisor category. The key phrase in the question is directly onto a physical server. Question 12. A technician installs VMware Workstation on a Windows 11 laptop and uses it to run an Ubuntu VM for testing. Which component is the host operating system? Ubuntu, VMware Workstation, Windows 11, or the virtual hard disk? Pause the video and choose the best answer. The correct answer here is C, Windows 11. Windows 11 is the host operating system because VMware Workstation is installed on top of it. Ubuntu is the guest OS. VMware Workstation is the Type 2 hypervisor. The virtual hard disk is storage used by the virtual machine. When you create a virtual machine, you need to assign it resources from the host. The main resources are CPU, RAM, storage, networking, and video memory, and sometimes USB or peripheral access. This is where beginners can make mistakes. They create a VM and they give it too much RAM or too many CPU cores. Then the host machine suddenly becomes slow. Or they give the VM too little RAM, and the guest OS system is what crawls. Virtualization is a huge balancing act, to be perfectly honest. The host machine still needs resources to run, and the VM is going to need some resources too. If your physical laptop has 8 GB of RAM and you assign 6 GB to one VM, you may be leaving too little RAM for the host operating system. That can cause things like freezing, slow performance, or even crashes. Storage also matters. Virtual hard disks consume space on the host. You may create a 100 GB virtual disk, but if the host drive is nearly full, the VM may fail, pause, or corrupt data. Networking also matters. A VM needs some type of virtual network configuration if it's going to communicate with the host, the local network, or the internet. For this episode, we're not going to go too deep into networking modes because we already covered networking already. The main point here is if a VM cannot reach anything, check whether the virtual network adapter is connected and whether it is using the correct virtual mode for the task. Don't assume the guest OS is broken just because it's not working. Question 3. A technician creates a virtual machine on a laptop with 8 GB of RAM. The technician assigns 6 GB of RAM to the virtual machine. After the virtual machine starts, both the VM and the laptop become very slow. What is most likely the cause? A, the VM doesn't have enough virtual storage. B, the host system doesn't have enough remaining memory. C, the VM is using a Type 1 hypervisor. Or D, the guest OS requires a bridge network adapter. Pause the video and choose the best answer. The correct answer here is B. The host system doesn't have enough remaining memory. The VM was assigned too much RAM, leaving too little for the host operating system. A could cause storage-related issues, but the scenario points more to memory pressure. C is incorrect because this is more likely a resource allocation issue, and D is completely unrelated to system-wide slowness. The biggest lesson here, don't starve the host. Now let's move on to containers. Containers are often mentioned in cloud and virtualization, but they are not exactly the same as traditional VMs. A VM includes a full guest OS. A container packages an application and its dependencies so it can run consistently across different environments. Containers are usually smaller and faster to start than full virtual machines. A common container platform is Docker. You may hear also about Kubernetes, which is used to manage containers at scale. For the A+, try not to overcomplicate this. You're not expected to become a Kubernetes engineer, just understand the basic difference. A virtual machine virtualizes an entire computer system. A container packages an application and what it needs to run. So here's a simple example. A developer builds a web application. On their laptop, the app works perfect. But when they move it to a server, it breaks because the server has different software versions. Containers help solve that problem by packaging the application with all dependencies so it behaves more consistently across the environment. This is why containers are popular for things like development, testing, cloud deployments, and modern applications. Question 14. A developer wants to package an application with its required libraries and dependencies so it runs consistently across different environments without creating a full virtual machine for each instance. Which technology best fits this need? A container, B, a Type 1 hypervisor, C, a virtual desktop, or D, full disk encryption. Pause the video and choose the best answer. The correct answer here is A, a container. Because containers package an application and its dependencies, so the application can run consistently across environments. A Type 1 hypervisor runs virtual machines, a virtual desktop provides a remote desktop experience, and full disk encryption protects storage, but does not package applications. Moving on to virtual desktops and remote applications. A virtual desktop lets a user access the desktop environment that's running somewhere else. Instead of the desktop running directly on the user's laptop, it may run in a data center or a cloud environment. The user connects to it remotely. You may hear terms like VDI, which stands for Virtual Desktop Infrastructure, or DaaS, which stands for Desktop as a Service. Remote desktop, cloud PC, virtual apps, published apps. The basic idea here is that the user sees and interacts with a desktop or application, but the computing work happens somewhere else. This can be very useful for remote work, contractors, temp staff, secure environments, and bring your own device situations. For example, a hospital, law firm, financial company, or call center may use virtual desktops so users can access company systems without storing all that data directly on their local device. But virtual desktops can create different troubleshooting questions. If a virtual desktop is slow, the issue may be something like the user's local device, the remote desktop session, the virtual desktop host, the user profile, the application inside of the virtual desktop, backend storage, authentication, licensing, or general service performance. The key is knowing where the application is actually running. If Microsoft Word is installed locally on the laptop, you troubleshoot the laptop. If Microsoft Word is running inside a virtual desktop, the local laptop may only be displaying the session. That is the difference that matters. Knowledge check 15. A user connects from a personal laptop to a company-managed Windows desktop running in the cloud. The user interacts with the desktop remotely, but the applications and data remain in the company environment. Which technology is being used here? SaaS, VDI or DaaS, local virtualization, or public key infrastructure? The correct answer is B, VDI or DaaS. This describes a virtual desktop. The desktop runs remotely while the user accesses it from another device. SaaS is a complete application, not an entire remote desktop. Local virtualization would run the VM on the user's own device. Public key infrastructure deals with certificates and encryption, not remote desktop delivery. Now let's talk about modern network services without repeating wireless network services. To avoid overlapping from the previous episode, we're not going to reteach Wi-Fi standards or anything like that. Instead, we're going to be focusing on services that modern users rely once they're connected. These include things like cloud storage, cloud backup, identity services, remote access, collaboration platforms, file synchronizations, cloud-based management tools, and hosted business applications. Let's start with cloud storage. Cloud storage allows users and companies to store files in a remote service instead of only a local hard drive or local file server. Examples include OneDrive, Google Drive, Dropbox, Box, and cloud object storage platforms. From a support perspective, cloud storage issues often involve things like sync problems, missing files, permissions, storage limits, conflicting file versions, deleted files, shared links, offline access, and user confusion over where the file is actually saved. A user may say something like, "Oh no, my file disappeared," but the file is really just in a different folder. Maybe it was saved locally instead of synced. Maybe it was deleted and can't be restored. Maybe the user just lost access. Maybe the sync client is paused. Maybe the account is out of storage. This is modern support work here. Next up is cloud backup. Cloud backup stores copies of data in a cloud service so it can be recovered after deletion, hardware failure, ransomware, or disaster. This is different from simple file sync. Sync is not always backup. That is worth repeating. Sync is not always backup. If a user deletes a file and that deletion syncs everywhere, the file may be gone unless version history, recycle bin, retention, or backup exists. Backups are about recovery. Sync is about keeping files available across devices. They're related, but they're not the same thing. Next up, identity services. Modern environments often use cloud identity platforms to manage sign-ins, users, groups, MFA, and access policies. Examples include Microsoft Entra ID, Okta, Google Identity Services, and similar platforms. From a help desk perspective, identity issues are everywhere. I can't emphasize that enough. Password resets, MFA prompts, locked accounts, disabled users, conditional access, group memberships, single sign-on issues, expired passwords, new phone setup for MFA. So the user come at you with saying something like, "The app is broken." But the real issue is that the user doesn't have the correct group membership, license, or sign-in approval. Next up, let's talk about remote access. Remote access is what allows users to reach company resources from outside of the office. This may involve VPNs, virtual desktops, remote apps, zero trust access platforms, or cloud-native applications. The support question is, what is the user trying to access and how are they supposed to access it? Are they using a VPN? Are they using a browser? Are they using remote desktop client? Are they using a SaaS app? Are they supposed to be on a company managed device? Are they blocked because of location, device compliance, or MFA? Again, the point here, don't just memorize every single vendor. The point is to understand the categories. Modern network services are about delivering access to applications, data, identity, and management from anywhere. Question 16. A user reports that files are visible in the web version of OneDrive, but not on their local laptop. Other OneDrive folders are syncing normally. What should the technician check first? Pause the video and choose the best answer. The correct answer here is A, whether the specific folder is selected for sync. If the files are visible in the web portal but missing locally, the issue may be folder sync selection, sync status, or local client configuration. B, C, and D don't directly address the issue. So this is a good example of not chasing unrelated hardware or cloud theory when the scenario points to a sync configuration problem. Question 17. A user deletes a folder from a cloud sync directory. The deletion syncs to the cloud and other devices. The user later says, "I thought cloud sync was my backup." Which statement is the most accurate? Pause the video, review the answers, and pick the best one. The correct answer here is B. Cloud Sync keeps files consistent across devices, however, backup is designed for recovery. Sync and backup are not the same thing. Sync keeps data consistent across locations, including deletions. Backup is designed to preserve recoverable copies. A is incorrect and honestly super dangerous. C is unrelated. D describes the opposite of backup. Now let's talk about the cloud troubleshooting mindset. When troubleshooting cloud, virtualization, and modern services, try to avoid tunnel vision as best you can. Don't just immediately blame the user's laptop, the cloud provider, or reinstall the application. Start by asking more focused questions. Who is affected? One user? 100 users? 1,000 users? Everybody in the world? What is affected? One app? all of the apps, one file, one virtual desktop, one login. When did it start? Did it start after a password change, after an MFA reset, after moving to a new device? Then isolate the layer. Check the local device, check the application, check the browser, check the licensing, check logs if you have access, check whether other users are affected. The difference here is between guessing and troubleshooting. A weak technician will say, just try rebooting the machine. A better technician says, let's figure out whether this is a local, account-related, permission-related, service-related, or it's affecting multiple users. Rebooting may still be useful, but it's not a strategy by itself. Question 18. A user cannot sign into a SaaS application after getting a new phone. The error appears after the password is accepted. Other users can sign in normally. What is most likely the issue? Pause the video and choose the best answer. The correct answer here is B. The user's MFA method needs to be updated or re-registered. The password is accepted, but the issue happens afterward. Since the user got a new phone, MFA is most likely the problem. A is unlikely because other users are able to sign in. C is unrelated because the issue is user-specific and occurs after their password entry. D has absolutely nothing to do with SaaS login. This is exactly the kind of real-world support issue that you will see constantly. Now let's go through some performance-based questions. For the first performance-based question, match each scenario to the correct cloud deployment model. Your options are public cloud, private cloud, hybrid cloud, community cloud. So here, scenario 1 is public cloud. Scenario 2 is private cloud. Scenario 3 is hybrid cloud. Scenario 4 is community cloud. Scenario 1, the company is using AWS, a third-party cloud provider, to host public-facing servers. Scenario 2, the environment is dedicated to one organization. Scenario 3, the company is using both on-prem and cloud resources. Scenario 4, multiple organizations have similar requirements, so they are sharing the environment. Performance-based question number 2. For this performance-based question, match each example to the correct service model. Your options here are IaaS, PaaS, SaaS. Pause the video and choose the best answer for each one. The answers are: Ticket 1 is IaaS. The technician is working with infrastructure, including virtual machine and operating system. Ticket 2 is PaaS. The developer is using a managed platform to run code without managing the underlying server operating system. Ticket 3 is SaaS. The user is consuming a complete cloud application. The easiest way to remember this, like I said before, IaaS stands for infrastructure, PaaS stands for platform, SaaS stands for software. So here, for performance-based question number 3, we see a mock virtualization setup. The scenario is that you're creating a basic Windows 11 test VM with specific host computer resources. The goal is to create a basic Windows 11 VM for light application testing while keeping your host stable. There are various configuration options. Select the best starting configuration. The best answer here is option B, where you give the guest VM 4 GB of RAM, 2 CPU cores, and 80 GB of virtual disk, which is a reasonable starting point for a basic test VM, leaving plenty of resources for the host operating system. Option A gives the virtual machine way too many resources and can starve the host. C nearly starves the host. D is likely too low for Windows 11. The key lesson here, again, is don't starve the host machine, and virtual machines share resources with the physical computer. Question 4. Here we see a ticket interface. The ticket shows that user Dana has the issue: my project files are missing from my laptop, but I can see them in the web version of OneDrive. You have several available actions. Select the 4 best troubleshooting actions. Now, on the test, you may see something like this, and they may ask you to put in a rank 1 through 4, but we're just going to select 4 of the best troubleshooting actions. We're not going to care as much about specific step-by-steps. The correct answers here are to check sync client status, verify the user is signed into the correct account, check whether sync is paused, verify the folder is selected for sync. This is most likely a cloud sync issue, not necessarily a hardware issue. If the files are visible in the web portal, then the cloud copy exists. Now you need to figure out why the local device is not syncing them. Now let's talk about an interview challenge. You're sitting down for an interview and the interviewer asks you, I can log into my laptop, but I can't access our company's cloud ticketing system. My coworker can access it just fine. Walk through how you would troubleshoot this. Pause the video and think through your answer. A strong answer would include things like confirm the exact error message, check whether the user can access other websites and cloud apps, test another browser or private browsing window, clear the cache or check browser extensions if needed, verify the user is using the correct URL, check the user's account status, check whether the user has the correct license, check group memberships or application permissions, check MFA status, check whether the user is blocked by a conditional access policy. The key point here is since the coworker can access the system, this may not be a full service outage per se. It may be a user specific issue. It may be permissions related. Good technicians will narrow down the problem before escalating the ticket. Now for a real world ticket scenario. A user says my virtual desktop is slow. A beginner might say, well, then your internet is bad. But that may not be true. Instead, you want to ask, is the local laptop slow or only the virtual desktop? Are other users having the same issue? Which, you'll have to figure that out on your own. The user won't know that. Is it slow during local login only? Is one application slow inside the virtual desktop or are all applications slow? This is why cloud and virtualization support requires layers of thinking. The user will only see one screen, but behind that screen, there may be a lot of different things all running about. A local device, a remote session, a virtual machine, identity, a user profile, backend storage, cloud platform, application server, and licensing. Your job is to figure out where that failure is happening. This is what separates guessing from troubleshooting. Here's what you actually need to remember for your A+ exam. We're going to simplify everything in a too long didn't read. For the A+, remember these core ideas. Cloud computing means consuming technology resources over a network service. Public cloud is provider owned and shared by many customers. Public cloud is provider owned and shared by many customers. Private cloud is dedicated to one organization. A hybrid cloud is a mix of public cloud and private or on-prem infrastructure. Community cloud is shared by organizations with similar needs. IaaS gives you infrastructure like virtual machines and storage. PaaS gives developers a managed platform for applications. SaaS gives users complete software over the internet. Shared responsibility means both the provider and customer have security and management duties. Virtualization allows one physical host to run multiple VMs. A hypervisor creates and manages virtual machines. Type 1 hypervisors run directly on hardware. Type 2 hypervisors run on top of an existing operating system. Containers package applications and dependencies. Virtual desktops allows users to access desktops or apps running somewhere else. Cloud storage sync is not the same thing as backup. Modern troubleshooting means checking the device, account, license, etc. That is the foundation. So in this episode, we moved beyond wireless connectivity. We looked at how modern IT services are delivered. We covered cloud computing and why companies use it. We broke down all the different cloud models. We compared some service models. We talked about what shared responsibility is. We explained concepts like virtualization, VMs, hypervisors, and containers. We looked at virtual desktops and remote applications. We also walked through cloud and virtualization troubleshooting scenarios that are common in the real IT world. The big takeaway here is that modern IT support is not just about the device that sits in front of you. You need to understand where the service actually lives, how the user accesses it, what account or license controls it, and what layer may actually be failing. That's how you move on from guessing to troubleshooting. In the next episode, we'll continue building your final Core 1 skills by moving into mobile devices, including laptops, tablets, smartphones, and mobile accessories, docking stations, and common support scenarios that you'll see in the real world. If this video helped you, consider subscribing for more beginner-friendly IT content and cybersecurity training. Drop a comment with one cloud or virtualization topic that you want explained in plain English. Thank you all so much for watching. Keep leveling up, keep studying, and I'll see you all in the next episode.